Okay, a cyclist goes on a training exercise every day. Oops. So this is just a sort of probability tree exercise. So he goes from his house in town A to town B, choosing one of three different routes with the following probabilities. So essentially, there's a choice between route 1, route 2, and route 3. Route 1 is 15 kilometers, and he chooses that about 20% of the time. Route 2 is 20 kilometers, and he chooses that 50% of the time. And route 3 is 25 kilometers, and he chooses that 30% of the time. Okay, so when he gets to town B, he'll return home to town A. So it's a sort of out and back, and he'll sort of do the same sort of thing. He'll make the same sort of choice. Go back, by route 1, route 2, or route 3. So just to give you a quick example here, on the way out, let's say he just picks route 1 for some reason, and that's 15 kilometers, and when he gets to town B, he goes back, and this time he decides to go by route 2. So altogether, the round trip is 40 kilometers. Okay, so here's the questions. What is the probability that the cyclist will cycle for 40 kilometers or more? What is the probability that he will cycle for 30 kilometers or less? Okay, actually, I'm just going to amend that to 35 kilometers. Okay, so just or less. I'm just going to sort of change that slightly. Okay, 35 kilometers or less. Okay, so what we're going to do here is use a probability tree approach. Okay, so what happens here, starting off, is that he's in town A, and he picks one of these routes, route 1, route 2, or route 3. Okay, and he gets to town B. Okay, and then he has to cycle back to town A. Okay, so when he gets to B, he'll go route 1, route 2, route 3, route 1, route 2, route 3, route 1, route 2, route 3. Okay, so and then he gets back to A. Okay, so the probability of route 1 is 0.2, 0.5, and 0.3. Okay, again, route 1, 0.2, 0.5, and 0.3. Okay, 0.2, 0.5, and 0.3. 0.2, 0.5, and 0.3. This is a bit tedious, actually, unfortunately. Okay, so there's 9 possible combinations. Okay, so for example, he goes route 1 and he comes back route 1. He goes route 1, he comes back route 2, and he goes route 1, comes back route 3, and so on. Okay, so there's 9 possible outcomes here. Okay, so for the first outcome, I'm just going to use a different color pen. This is route 1 out, route 1 back. Okay, now the probability of that is simply what we do here is multiply for each leg, so to speak, from the root node to the terminal node, multiply the probabilities of each stage, so to speak. So 0.2 times 0.2, and that is 0.04. Okay, route 1 out, route 2 back, 0.2 by 0.5, that's 0.10. Route 1 out, route 3 back is 0.2 by 0.3, that's 0.06. I'm just going to fill in the rest here. Route 2, route 1 is 0.5 by 0.2, which is 0.10. Route 2 equals 0.25. Route 2, route 3 equals 0.15. Route 3, route 2 equals 0.06. Route 3, sorry, that's route 1. Route 2 equals 0.15, and route 3 equals 0.09. Okay. Now you probably don't have to go, I mean, actually what might help there is actually give yourself more space. I've sort of bunched it up quite a lot. Okay. What I'm also going to do actually is just to actually sort of route 1 out, route 2 back. That is what I'm going to do. Actually, sort of set up a little table, and we'll just to sort of just help us visualize those results a little bit better. Okay. So I'm just going to pause it here. So there we have it there. What I'm going to do is I'm going to use this table here just to help us. So it's essentially just to sort of tabulate all of the results that I've used, everything I built up there. Just actually really to make it easier to follow from the point of view of the YouTube video. So the overall route, essentially route 1 out, route 1 back, there's 4% of that probability of that happening. And the distance of that route is 30 kilometers, as in 15 plus 15. Route 1 out, route 1 back, 15 plus 15, 30 kilometers, and so on. So essentially what we have here is a little table, okay? Now something you could do actually is just actually, this is not part of this exercise, but you can actually sort of condense that table into the probability of cycling a certain distance. For example, the probability of cycling 40 kilometers is 25 plus 15, which is 6%, 25% and 6%. So that is about 37% probability of cycling 40 kilometers. You can build up a little table like that. Okay, that's not exactly what we are doing here. What we are doing here, I'm just going to leave that table actually in the background here and just put the page down just as I need to. So what we were interested in is the probability of more than 40 kilometers, which is actually this one here, route 1 plus route 3. Okay. Sorry, I'm just going to pause this and get the page back out. Okay, so I just unpaused it there for a second. I just had to do a little quick fix up. So essentially what I'm going to do here is point out, so that first off actually, I'll just actually ask the question here. The probability where x is greater than 40, okay? So x is the distance that the cyclist travels, okay? So what I'm going to do here is just count them out. So route 1, route 3, route 1 out, route 3 back, that's 40 kilometers. Route 2 out, route 2 back, 40 kilometers. Route 2 out, route 3 back, 40 kilometers. And basically, if he starts out with route 3, route 1, route 2, route 3, that is 40 kilometers, 45 kilometers, and 50 kilometers. So all three of these together. In fact, actually, I'm just going to sort of tot them up singularly, or as one as 30%. That adds up to 30%. Okay. So let's just actually tot them up here. So that is route 1, route 3 is 6% chance of that happening. Okay, so I just write it in there, 0.06. 0.2 and 0.2 is not, route 2 is 0.25. Let's just check that. Yeah, there it is. Route 2 and route 3 is 0.15. Okay, just check that there. And again, I'll just put in all of these three together in one go as 0.30. Okay, so it turns out that there is a 76% probability, if you just add them all up together, so 30 plus 50, so that's 70 plus 6, yeah, 76%, okay, probability that the cyclist will travel 40 kilometers or more. Okay, so the next one is less than 35. I just changed it in the question to less than 35. So it is essentially, it's going to be the complement, okay, but because just the sort of the unit step. So if he travels 40 kilometers or more, yeah, I mean you can't travel between. You can't travel, according to this, you can't travel between 36 to 39 kilometers. It goes up in unit steps of 5. Let's just double check it anyway. 4% plus 10% plus 10%. Okay, so it's this one here is 30 kilometers. This one here, 35 kilometers. This one here, 35 kilometers. It is actually 24%. Now we can actually work it out on the basis that it is the complement of greater than or equal to 40, but you can also work it out separately as well. So it actually works out to be, again, just to be clear, 24%, which is 4%, 10%, and 10% together. Okay, that's a bit wobbly there. So that is Yeah, we'll leave it there. That's grand.